This video will be about simplifying radical expressions. So a radical expression is any expression involving the square root symbol. You can also change the square root symbol by putting a little number in the check mark. That would change it to the cube root or to the fourth root if I put a little 4 there. And the difference is, when you have the square root symbol, it's saying what number multiplied by itself. So 2 times 2 equals 4. What number multiplied it by itself equals the number inside, so the square root of 4 is 2. If I'm doing cube root, then you're asking yourself what number multiplied by itself 3 times equals the number inside. So groups of 2 for square root, groups of 3 for cube root, so the cube root of 8 is 2, and groups of 4 for the fourth root, so on so forth. I think we only really work with the cube root on this assignment, the square root and the cube root. So fourth root of 16 would be 2. So we're going to be working with multiplication and division of these radical expressions. So when you're multiplying radical expressions, you can only multiply the numbers outside of the radicals together and the numbers inside the radicals together. So we would do 5 times 3 is 15, 10 times 5 is 50. And once you've multiplied them together, then we can simplify. There's another method where you simplify the radicals first and then multiply. I prefer to multiply first because if you simplify first, then multiply, you may have to simplify again. So I like to have less steps involved. So when you go to simplify this radical, we do that using a factor tree. First, I need two numbers that multiply to be 50. 5 times 10. And we only have to simplify the stuff inside the radical. The 15 is just going to stay a 15 unless we end up having to multiply by something else. Then we keep breaking down. 5 is called a prime number because the only way to break it down would be 1 times 5. If you get the 1 in your multiplication, that's what makes it prime, and we don't want to include that on our factor tree. So 50 is gone since we split it up. 10 will disappear once we split it up to be 2 times 5. So now we have 2 times 5 times 5. Well, when we were looking up at the square root, we said groups of 2 were important. And the reason is because when we have 2 of the same number, then the square root of that is going to be just one of those numbers. So one of them is basically going to disappear. The square root of those two together will bring one of them outside. It's like you're doing the square root of 25 because 5 times 5 is 25, and the square root of 25 is 5. I usually remember it as get rid of 1, take 1 outside. There's already a 15 out there, so it's going to have to multiply by the 15 that's already out there. 15 times 5 is 75, so we would get 75 square root 2. We moved this 5 to the outside, so it's not in there anymore, and one of the 5's canceled. They will also have some variables involved in these problems. So this time let's try one with a cube root. Okay, so on this problem, there's only the negative 3 outside. There's nothing in front of the other one, so we just leave the negative 3. And then we multiply everything inside together. 4 times 4 is 16. X squared times x is x to the third. Y times y is y to the second. Then we've got to break this down. 16 would be 4 times 4. We don't have the 16 anymore. 4 times 4 4 is 2 times 2. The other 4 is also 2 times 2. X to the third we can also break down. When it's to the third, that means multiply x by itself 3 times. Or y to the second, multiply y by itself 2 times. And we are looking for groups of 3. We have 3 2's here, 3 x's here. Those are the only groups of 3. So when we do this, I kind of have a little story to also help me remember how I work through this. So this radical piece, it's kind of like the jailhouse. And all these guys inside are inmates, and they're trying to make their way and break out of jail. So all the 2's are planning together a way to escape. And as they make their escape, only one of them makes it out alive. The other 2 get shot by the guards. So 2 of them are dead. One of them makes it out of the prison. It's kind of a depressing story, but kind of helps you remember this is what you do. This poor little 2 all on its own didn't have anyone to plan a breakout with, so he was stuck inside. It's the same thing with the x's. One of them makes it out alive. The other 2 don't make it. And then the y's, they didn't have enough people to plan the breakout, so they're still left inside. And if there was a number outside, it's still going to remain outside. And this will still be multiply. So then we multiply everything back together. Negative 3 times 2 is negative 6x. And then 2y times y is y squared. Now I can't quite remember if I said specifically that the reason we're looking for groups of 3 this time is because it was the cube root. It had the little 3. If it was the square root, we'd look for groups of 2 again. So cube root, we look for groups of 3. Square root, we look for groups of 2. So the last thing when you're multiplying radicals or when you're dividing radicals to keep in mind is when you're doing square root of a negative number. That is impossible. Square root of a negative number is not possible, whereas cube root of a negative number is possible. So that's one little detail you have to keep remembering as you go through. Square root of a negative number, can't do it. Cube root of a negative number, you can. So the second topic for this is dividing radicals. So when you are dividing radicals, there's kind of 3 methods you have to use. Okay. The first method, square root of 36 over 9. This happens when I can't actually divide that. If I divided 36 by 9, that gives me, oh, I chose a bad example. I was just writing it random. Let's try something that will actually do the point I was going to say. Let's say 36 over 25. Okay, if I actually divide 36 by 25, I get 1.44. We don't want to be working with decimals, so we can't do it that way. Whereas on the second one, if I did 72 divided by 8, I can actually do that. 72 divided by 8 would be 9. Now you also notice they each have the square root in a different spot. This one, the square root is around everything. This one, each piece has its own square root. Well, you can actually move that back and forth as much as you want. This first one, I could rewrite it so they're separate if I felt like it, and actually that's something you will need to do. The second one, I could write it so they're all under a square root and still be fine. That's one of the properties of our division, was we can kind of change that back and forth because sometimes we need it to be one way, sometimes we need it to be the other. So when it came out as the decimal, we want them to have separate square roots, because then we want to check and see if each individual square root can actually be square rooted. So square root of 36, if I reduce 36 down by doing my factor tree, I get 6 times 6. 6 will break down to be 2 times 3. And the other 6 will also break down to be 2 times 3. So square root of 36 is really 2 times 2 times 3 times 3. It is square root, so we're looking for groups of 2. 1 dies, 1 makes it out alive. So we now have a 2 outside the square root. 1 dies, 1 makes it out alive. We have a 3 outside the square root. This one's kind of tricky. Now there's nothing left inside the square root. Well, if this were a jail with no prisoners inside, they'd knock it down because it's not necessary anymore. So the square root of 36 is just 6. Okay, so now we have to do the same thing with 25. Square root of 25, we break it down, that's 5 times 5. Can't break down anymore. So, looking for groups of 2, this one has the same thing happen. We just get 5. So 6 over 5 would be our final answer on this one. Again, we did it that way because when we did the division, we got a decimal. We don't want to work with decimals. So this second example, when we did the division, we got a nice number, 9. So we're going to reduce this number 9. 9 is 3 times 3. We look for groups of 2. 1 makes it out, and there's nothing left inside, so we knock down the square root and just have 3 as our answer. The last kind, we would try the division first. If we had it all under 1, 5 divided by 2 is 2.5, so that didn't work. We would try reducing it. Square root of 5, well, 5 is already prime, I just have 5 times 1. So I don't have any groups of 2, so that doesn't work. So we need a third method to take care of this one. The third method is called rationalizing the denominator. So the purpose of rationalizing the denominator is to get rid of the square root on the bottom. And the way we do that is we are going to multiply top and bottom by a square root. We're going to pick the square root that's already on the bottom and multiply it to the top and to the bottom of the original fraction. So we know how to multiply because we just did that with our square roots. Square root of 5 times square root of 2 is square root of 10. Square root of 2 times square root of 2 is square root of 4. So now that we've multiplied it out, now we try and simplify again, and when we do, this bottom one is going to simplify super nicely for us. 10 is 2 times 5. They won't simplify any further, so that's as simple as it can be. But if we do square root of 4, that's 2 times 2. We do have a group of 2. 1 gets crossed out, 1 goes in front. So this would become square root of 10, that didn't change, over 2. So that finishes our topics of multiplying radicals and dividing radicals and simplifying them.